Okay, second example. Hopefully, like I said, after a little bit of time of thought, you have come up with some idea here. And hopefully example A kind of prompted your brain to think outside the box here. This question's a little bit more intriguing than maybe that first one was. So what does our quadratic need to equal in order for this whole entire expression to equal 1? And think about it. Any number when raised to any power that always equals 1, well, that's 1. So this expression, because if you think about it, before we even set the quadratic up, what if that whole entire quadratic was 1? 1 to the 6th power would equal 1. Okay? What about if that whole entire quadratic was -1? Is -1 to the 6th power? Remember, any negative number to an even power is always going to be positive. So -1 to the 6th power is also going to be +1. So these are our thought processes for this one. Okay? So let's go ahead and get to work. Let's set each of these up. Let me get a better color than that. Then hopefully you guys can see. Let's set x squared minus 3x plus 1 equal to 1. And then let's do the other one. Let's go with this color. Let's do x squared minus 3x plus 1 is equal to -1. Okay, so we're going to solve each of these quadratics and see what we get, okay? So let's go back to this first one that we did. Anytime you're solving a quadratic, guys, that has an x squared term and an x, you want to get everything equal to 0, okay? So you need to move this 1 over here to the side. So you have x squared minus 3x. Now when you minus 1, that's going to cancel out. So we're to here, okay? Now we have to have this mindset we're solving by factoring, okay? I cannot just divide everything by x because I'm potentially losing an answer. So if I factor out an x, then I come up with this expression. And I'm setting each piece equal to 0. So I get x is equal to 0 or x is equal to 3. Okay, so I come up with these two over here. Now let's go back to the second equation that we came up with. So if I move this -1 over here to set the expression equal to 0, I have, if I add 1, then I have a 2. Okay, now let's think about it. I'm factoring this quadratic, and factoring, once again, is going to look a little bit different because my leading coefficient's a 1. So I can jump right to the faster version of factoring and say what multiplies to be 2 that adds up to -3. And I go right into my factors, and it's -2 and -1. Now you can write those parentheses in any order. The x minus 1 could come first, followed by the x minus 2. Totally fine, because you can multiply in any order. So you get x equals 2 or x equals 1. Now, none of my answer is repeated. I always just want to double check that so I don't list anything twice. But that's it.